Picture this. It's 1966. You board a gleaming Boeing 707 at JFK, settle into your seat, and the captain announces your cruising speed, nearly Mach 0.90, about 600 miles per hour. Fast forward to today. You board a state-of-the-art Boeing 787 Dreamliner, packed with the latest technology, and the captain announces a cruising speed of around Mach 0.85, roughly 570 miles per hour. Wait, did we just go backwards? The answer is yes. And the reason why tells us everything about how the aviation industry actually works. The golden age of speed. The jet age of the 1960s was a technological arms race. Airlines were competing on prestige and novelty. Speed was glamour. The Boeing 707, the Douglas DC-8, the Convair 990. These aircraft routinely cruised at Mach 0.88 to 0.91. The Convair 990 was specifically engineered to cruise at Mach 0.91, making it the fastest subsonic commercial jet ever built. Flying fast was the whole point. But here's what nobody talked about at the time. It was colossally expensive to do so. The physics nobody wanted to discuss. At subsonic speeds, a curious thing happens as you approach Mach 1. Air can't get out of the way fast enough. Pockets of airflow over the wing begin going supersonic, even while the aircraft itself is still subsonic, creating shock waves, buffeting, and a sudden, dramatic spike in drag. This is called wave drag, and it doesn't creep up on you gently. It hits like a wall. The relationship between speed and drag isn't linear, it's exponential, going from Mach 0.82 to Mach 0.85 burns noticeably more fuel. Going from Mach 0.85 to Mach 0.90. You're burning fuel at a rate that eats into profits like nothing else. The 1960s airlines knew this, they just didn't care, because fuel was cheap, tickets were expensive, and the passenger who could afford to fly at all was not price sensitive. The 1973 oil shock changed everything. Then came October 1973. OPEC's oil embargo quadrupled fuel prices virtually overnight, and the economics of aviation were turned upside down. Suddenly, cruising at Mach 0.90 wasn't glamorous, it was reckless. Airlines began throttling back, and aerospace engineers received a very clear new mandate: efficiency, not speed. Every generation of commercial aircraft since then has been optimized around a specific sweet spot, typically Mach 0.82 to 0.85, where fuel burn is dramatically lower, while the time penalty is surprisingly small. Think about it this way. On a 6-hour transatlantic flight, flying at Mach 0.85 instead of Mach 0.90 adds only about 20 to 25 minutes, but it saves thousands of kilograms of fuel. Multiply that across hundreds of flights per day, and you're talking about savings in the hundreds of millions of dollars annually for a major carrier. Modern engineering, faster at being efficient. Here's the irony that makes this story genuinely remarkable. Today's aircraft, the Airbus A350, the Boeing 787, the A220, are engineering masterpieces. Their carbon fiber fuselages are lighter and stronger than aluminum. Their engines, like the GE9X and Trent XWB, are marvels of thermodynamic efficiency. Their wings use advanced aerodynamic profiles called supercritical wings, specifically designed to delay the onset of wave drag and reduce it at cruise speeds. All of that innovation has been poured not into going faster, but into going farther, cheaper, and quieter, at a speed that was already known to be optimal. The 787 uses roughly 25% less fuel per passenger than the 767 it replaced. Not because it flies at a different speed, but because every single other variable has been optimized around that same Mach 0.85 target. The Concorde question. Now, you might ask, what about the Concorde? Didn't supersonic travel solve this? In a sense, the Concorde proved the problem. It cruised at Mach 2, more than twice the speed of sound, but burned so much fuel that tickets cost the equivalent of $12,000 or more in today's money. It was reserved for heads of state and investment bankers. Concorde was retired in 2003, not because the technology failed, but because the economics never worked for anyone but the ultra-wealthy. New supersonic startups like Boom Supersonic are trying to crack this problem today, but the fundamental physics, wave drag, fuel burn, sonic booms over land, haven't changed. So, the next time you're sitting in a modern airliner, cruising at only 570 miles per hour, consider what you're actually experiencing. You're flying in an aircraft that travels farther on less fuel than anything that existed in the 1960s, at a ticket price affordable to hundreds of millions of people rather than thousands. The aviation industry didn't get slower because it failed. It got slower because it got smarter. Speed was the dream of the past. Efficiency is the engineering of the present, and they are not the same thing.